Hello and welcome to the third and last part of this video series, Long Distance Performance Benchmarking. Previously, we have run user experience test, bandwidth test, high concurrency, connection rate, and video quality of experience test, right? So in this part, we are going to run a lot of application traffic through this long distance network and see how it behaves. Then we are going to introduce some impairments, some delays between these networks and see how resilient these networks are in gaining back to its previous state after the impairment is removed. We're also going to run traffic for a longer duration to see any inconsistencies over a longer period of traffic flow. And we are going to explore additional tests that might be relevant in this kind of networks.
Now that we have understood the raw bandwidth, concurrency, connection rate, packet rate, how UDP traffic behaves, how voice video traffic behaves, the only thing left to do is relate this with realistic application mixes and application traffic, thereby replicating scenarios where users are sending application traffic data over these long distance networks. This would let us collect unique benchmark numbers for the network when real application and application patterns are sent through it. So my topology is still the same. As you can see, the network. I have my local client going to the remote website. I have 1,000 users and I have this new set of application mixes, right? So you see Jira transactions, Office 365, Salesforce, and such. Let's dive straight to the statistics. So I can now see the total bandwidth. You already know that's kind of the limit our network can go to, 6.5 Gbps. You can see with 100 users doing this traffic, my connection rate is at 2,500. My request rate is at a staggering 30,000. This is my average latencies for all the TCP connections. And you can also see how good my network is in maintaining those proportions of applications and different application traffic. So this gives me an overview of how the network does, not just for theoretical TCP, UDP, RTP streams, but with real applications. And you can even drill down into individual application statistics to look at transactions and if there is any problems with particular transactions, like sometimes the voice, video, or upload, download transactions can have problems. You can also look at failures, retries, and anything unusual. After sending all the good traffic, it's time to understand how our network handles chaos and how resilient it is when some untoward situation occurs. See, long distance networks are particularly susceptible to variety of situations and issues that can arise, like deep sea cable cut, some satellite link missing. So it's very important to test not just the raw performance numbers, but also the reliability and resiliency of the network when such incidents happens. So in this test, we're going to introduce forcefully certain types of issues in between the links through impairment tools and some manual configurations to see whether the network can bounce back after a problematic event is occurred. So we get back to our test config. I'm going to leverage a similar config that we have used in the past. I'm going to have the HTTP traffic with 2,500 users and a gig of throughput. So we are trying to limit the throughput to lower value. And we're keeping it simple for now, right? Just a 40K page size. So in the failures, what we did is that we introduced some level of disruption, service disruptions between these two endpoints, changing security groups. And you can see every time there is a disruption, the traffic goes down. But what's important is that it's coming back to that same level after that. And that can be reflected through latencies and overall transactions. The TCP statistics will show some retransmissions and aborts, which obviously is expected because there is a massive disruption. I can also see in the HTTP statistics some of the application failures. So the tool measures the failures and also any kind of issues and how resilient the system is in recovering through the failures. And we have just introduced one type of impairment here. You can introduce delays, drops, packet reordering, and various types of impairments in between these networks and test out how good or how resilient the infrastructure is in handling all of them. The last test in this methodology would be a long duration baseline monitoring. Most of the times the tests that we do, like the speed test and all, would always give us a point in time snapshot. And anytime you repeat the test after a certain duration, you will see a different result, right? So this test is all about running a particular type of config for a prolonged duration to look at the network latencies, packet rates, bandwidth, and any deviations that may happen during this duration. This gives you more trust towards the network on how it can not just achieve a peak bandwidth and peak packet rate, but also maintain it for a prolonged duration. We start with the same kind of config. We have 2500 users, again 1 gig. We don't want to stress the long duration test with a lot of throughput. The HTTP gets again is very common, 40k bytes, trying to be sensitive to this duration of the test. We kept the test running for certain amount of time, certain large time. You can see it kept pretty steady. And Cypress gives you the flexibility to look at a particular time range. And you can always slice it to see, okay, what happened for the last 1 hour or last 20 minutes to see any kind of deviations, any problems. So at least from the statistics side, we see that this particular network can maintain some level of throughput steadily over the long duration. Obviously, you can try it with the super high rates that we went to find the max bandwidth, like 6 gigs or 80,000 connections per second. And that's where you will probably see some issues. We did see some issues there. But at least for a reasonable bandwidth, it stays steady. And the retransmit, there are certain retransmit that goes up, but overall, not a lot of failures. In this video, we covered a lot of different types of traffic parameters like connection rate, concurrency, quality of experience. But if you're going beyond that, you can try other types of traffic, like if this long distance network is secured by sending exploits, malware, DDoS traffic. And apart from these, you can also add more attacks, more traffic profiles. You can look at the application mixes that we used previously and decide to add some encryptions, right? So TLS 1.2 or 1.3 to test any man-in-the-middle system that is looking at proxies, deep packet inspections. I can also go and edit the network stack to introduce elements such as IPsec, which is generally used for connecting long-distance networks, VPNs, other v4, v6s. I can even go into the middle stack and look at adding more complex devices under test like SASE, CASB, zero trust network accesses, load balancers that are listening to different ports. So any kind of security and application aware mechanisms that sits in between. Similarly, I can go into Cyperf's capture application builder libraries where you can upload any kind of captures and create your own set of applications that you can use just like any other regular applications to test the network with exactly the traffic that you might be seeing in that network. That brings me to the close of this video where we ran a large number of tests over this long distance network. The entire test methodology with the results have been posted in the description, so you look for the PDF file there. And all the configurations that I used is also there in a GitHub link, which has been added to this description. Thanks a lot for listening.